In this video, I'm gonna shortly introduce you to the overall envisioned architecture and including the envisioned pipeline that we're gonna use to facilitate what is known as continuous delivery. You probably heard about continuous delivery. It's kind of the, yeah, uh, you have continuous integration and where you can build things and compiling and test things automatically in an automatic way. Continuous delivery means that you can actually you extend that pipeline so you can actually deploy more or less automatically to different environments, including the customer environments, so they can test things and feedback on things, and finally to the production. So this concept of continuous delivery is, in my view, maybe the most important thing in the whole project. I mean, uh, to do in a professional and ambitious way. The reason I believe in that is because we have a little experience with this, and it's really I mean, when you have tried to do something like this, I mean you will never do it the old-fashioned way anymore, because it just, I mean, makes things go more smoothly, and you can the iteration, the cycle time from development, creating some feature so we can get feedback on that feature is much faster. Um, um, the Now this drawing here, this is um, this is just a proposal. We will, of course, when we start build this pipeline, and actually we have already started it to do some of the stuff. When we do that, of course, we will get wiser, and we're going to change things, and we're going to optimize things. So this is kind of my kind of proposal how we might, start up. And also, as you see to the left here, you can see some different types of developers, and this is very stereotypical kind of uh, shown here. Uh, and I mean, it doesn't necessarily have to be like this. I mean, and also what the developer do. I mean, now this is a DS development, this is some kind of UX development, this is a backend development. This is maybe not the best way to divide things up. If we're following some kind of microservice philosophy, we might maybe say that some developer has a slice of functionality. So for example, one developer could be expert in, I don't know, it could be like all about the map, and they actually, you know, do the UI, and they do maybe also the service behind that drives this map, and so forth, and persistence and everything. So the raised divider up here is just an example. The point of this is to kind of show that it's possible for the developers to work on part of the system and, you know, um, use other part of the system that they might not be working on, and get them running on their development environment and very quickly. So basically, you have to be able to spin up at your development environment, get all the services provisioned in there very fast, and you can go start working on some features in that environment. And then you can, when you're finished working on your stuff, you commit it to GitHub, or you push the code, and then this pipeline will start and build the stuff and put it to some Docker Hub or Docker registry, whatever, and then it will be deployed to a internal development environment or test environment. I call it here. Maybe it's one, maybe several environments. I don't know yet. Of course, things will only get deployed here if the test is green. I mean, all the unit tests are okay, and there will be some integration tests that test that the things work together. And if everything is fine in the automatic testing, we will just deploy to some server. We're going to run this in the cloud, everything, of course. So the whole idea is that because this project here, we will have different developers sitting different places. I mean, I will sit here in Denmark and do some stuff in one part of Denmark. That will sit something in another part of Denmark and do some stuff, and someone in other part of the world. And this is so it's just crucial that we have like this kind of environment so we can quickly do something, commit it, push it, and see if we have our stuff actually work together with the other stuff that's being worked on, right? And also very important is, of course, that we can do some stuff, we can optimize some stuff, and we can get it all the way to the customer very easily. And then the customer can check it and get feedback to us very fast. So I'm thinking of like sprints of like 1 week, for example, maybe 2 weeks, but not more than that. So we do some stuff. Um, you know, the customer has given us some feedback on something we already did, and they want, okay, they like to have this and this uh, new functionality, or maybe optimize some stuff, and we work on that. And then after, say, 1 week, they can actually test it here. So the idea is from this line here, we will post functionality maybe every week. Here on our own system, we're gonna do that basically every day. So when we do stuff and work on the product, the idea is we work on every time we have finished some piece of code, we're gonna push it up to make sure that it can pass all the tests and it works together with the other services that some other people is working on, right? So yeah, this I mean, this for developers, this is not new stuff. It's yeah, it's quite normal today to do it like this. At least the continuous integration part. Um, but what I like to focus on this project is that we also have the, the, the continuous delivery part into the pipeline too. So we can run fast. In my opinion, it's this stuff here is the stuff that's gonna make our system better than the others. It's not that we are smarter or better developers or have smarter customers or something. This is not what makes the system really good. What makes the system really good is how fast we can go from doing some changes in the code to reliable deliver that change to the customer, and they can check it and figure out does it give them any value. That this loop here is really, really important. And if you want to compete in this world, this is I really think this is what we have to focus a lot on, because we cannot make the best system or the perfect system from the start. It's impossible. We have to do a lot of iterations. And this is where how we make really good systems and optimize it. And if you look at existing systems that are running today, the existing DS system that the customer use, it should be pretty easy to beat them because they are extremely slow to, I mean, upgrade and put changes in. We can see that it takes maybe months, maybe even years before someone do something here to the customer can actually use that functionality. And this is because they have never been built with a continuous delivery mindset. So everything is done manually. Also typical, the existing system are built like one big piece of code. So you compile everything together in one executable. And then it starts up like a big fat desktop program. That's pretty much how many of the systems work today. And it's just very, very difficult to put new functionality in them. And when you create functionality, it's very difficult to do that without breaking something because they don't have any automatic test. They okay, maybe they have some automatic tests. I'm not saying that they don't have it, but we can see that the time it takes to put new functionality in is a really, really long time, and it costs a lot of money. So the idea is we have to be able to do that much more efficient, much more fast than the existing systems. There's this guy who is famous for um, has defined this. I don't know if he has defined this concept, but he has created some books. Uh, the book that's called Continuous Delivery. His name is Jess Humble, and he has done this book with another guy. He also did the book called Lean Enterprise that I like a lot. And what he says is, and I believe that's true, is that there are kind of two things that will make this stuff here work really efficient. And then that is a culture. So you have to have a culture in your team, that you kind of think in this way. So, I mean, the developers and also the customers, everyone has to kind of get this process, get this way of thinking that everything has to be automated and very easily deployed. They have to get that under the skin. And of course, you only get it under your skin if you work with it a lot. That's one thing. So it's a kind of a culture thing. And the other thing is that you have to make your architecture of your system so it kind of supports this kind of pipeline. If you have to sync that in. And this and here comes the part where I'm going to talk a little about the architecture and the vision for the architecture in this system on a very, very overall level. What is the whole idea is that we're going to divide the solution into actually several subsystems, you can say. So I have started to kind of divide things in like this, but I'm not saying this is the way we should divide it up. We might quickly find out that we might divide it up differently. Because I have no idea. I don't know about some front end. I just said, okay, this is one part. Maybe that's bad. Maybe the front end had to be divided up too. But that's something we have to, figure out. But the back end part, I know quite a bit about, and I'm able to create services that are very loosely coupled. So the idea is here we have different services that kind of focus on a specific part of the domain. So for example, we have this mapping service which focus on the root network and all the functionality that is needed there to kind of edit that root network and so forth. Then we have an equipment service that kind of deals with everything that kind of be put into that root network. All the stuff inside it and cables and conduits and connectivity and stuff like that. There will be other services as well. For example, there will be one called a circuit service or logical network service that kind of handles all the communication with all systems in terms of if you change some connectivity in the network, you're going to provide information to other systems, so-called provisioning systems, so they can provision the customer, change them. For example, if you move customer from one central office to another, there will be some functionality in this system here that actually can create all the transactions needed to reprovisioning all these customers. This is a kind of area that is very useful, very important for the telco customer to be able to do that efficiently and quickly and very reliable because when you fiddle with stuff like that, customer you have to minimize the downtime on the customer. And there will be a module that can do like that. And it's an area that is really I mean, it's very different from these, right? So there's no need to kind of put it together, right? So we're gonna divide things up like this. Uh, well, there will also be other services I can think of, like some asset management. Asset management is not something they put that much effort into when we're talking telcos yet. I mean, some begin to talk a little about it. That would be nice to know what kind of asset they have, how old they are, when has they been maintained, installed, and maybe you have problem with a certain kind of equipment. So where is that installed, and blah 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 blah. Work order management and all kind of stuff. And again, we will probably get service that handles stuff like this too, because when the customer begins to use this system, what happens is that they say, oh, we also need that, we also need that, we also need that. That's always what happens. So, and what typical have with the typical system when we don't have a strategy for dividing things up is that it become like one big ball of mud very quickly, and suddenly it's really difficult to change anything, and the system become like very difficult for the user to use, and it's gonna be slow, and because you kind of have no strategy to kind of divide things up in modules or service or whatever you call them. So this is a very overall kind of idea, concept here that we're gonna try follow, and I think it's gonna be really, really exciting to do this stuff. I mean, my experience with this is if you do this stuff, it's really cool. I mean, you can really do stuff that people working with the old legacy system they have more difficulties. It's actually possible to do the exact same stuff no matter what kind of environment you have. You don't need Docker to do this stuff, not at all. But it's just much easier because if we use technology, for example, like Docker, from the start, it will be much easier for us to get this stuff running very efficiently. Um, in terms of the environments, it's also so that customer might have some specific requirement in terms of what environment they want to run on. Some of the telco customer are, Microsoft customer kind of, they want to run things in Asia, for example. So the good thing about having Docker is that, okay, we can get this stuff to run on, we can get it to run on Azure, we can get it to run on Amazon or whatever cloud platform the customer like to use. And internally, we can choose whatever platform we like to use. So we're not tied to a particular platform. That's really important that we don't tie ourselves to a particular platform. I have actually tried to do that. I was so stupid that I have used some kind of Azure. I think it was functions or something it's called. And that was really stupid because I began to use some Microsoft specific stuff. And suddenly I found out that actually it sucks. It was not good. And then I have to kind of basically throw everything out and do it differently. So I try to utilize some cloud platform functionality to uh, to gain time, you could say. But I actually got punished because I tied myself to a specific platform, and that was really stupid of me. So I have some experience with this that I really, really, really want to make sure that we create something that can run on that's not tied to a particular platform. Another thing also very important for me is that this, as a developer, you can really quickly get up running. You can get the service to your own system, and it will just work. Because different stuff can be difficult to get running. For example, if you have some backend stuff, maybe there's some service that communicate with each other using RabbitMQ or whatever. We're using some messaging, and it can be difficult to get up running if you don't have automatic provisioning and stuff like that. And also UI stuff running in some RIP servers and all kind of things and ports and sites and whatnot. I'm not a web developer, but every time I have to get some things up running that a web developer has created, I always struggle to get it to work. So the idea is I could just get these containers down to my machine, spin them up, and then we are running. That's a goal here. So, um, so I hope that I hope it gave you a little inspiration and also kind of idea where we are going. Um, it's not like we can make the perfect continuous delivery pipeline from the start. We will start in the small and then we're gonna optimize it. But we're gonna put some effort into this, and we're gonna put some effort into make our code testable and also the integration test, so that we are pretty sure when we do some changes that if we something goes wrong, then this part here, this build test push part will actually tell us this stuff here is not gonna work in production. So this is really nice. You know, the whole test-driven development kind of philosophy. It's really it really improves. I mean, the customer satisfaction because they will actually get something that actually work, and it's not like when we change something, there's something else that's not working. this is what we experience a lot in existing DS systems that is used by telcos. Uh, at least the old legacy ones, but also some of the new ones actually also have these problems. And this is what we're gonna avoid with this thing here. So I hope it gave it make a little sense. So I think I'm gonna stop doing YouTube videos today because I think I'm mumbling too much and I think it's not good. but but you know, now I have created this one. I think this one was important. So yeah, see you.